Close your eyes now and breathe deeply. Let yourself settle into comfort as we begin a gentle journey through one of the most familiar yet miraculous inventions of the modern world, the automatic door. Imagine yourself standing before a building on a quiet evening. The sun is setting, painting the sky in shades of lavender and gold. Before you stands a pair of glass doors, still and silent, waiting. You take a step forward, and something magical happens. Without your touch, without effort, the doors glide, open with a soft, pneumatic hiss, welcoming you inside. That sound, that gentle whoosh of compressed air, is the breath of modern convenience. The pneumatic system that creates this whisper uses air pressure, stored and released through carefully calibrated cylinders. When the door receives its signal to open, pressurized air flows through valves at precisely controlled rates, pushing pistons that move the door panels smoothly along their tracks. It's the same principle that has powered machinery since the ancient Greeks discovered pneumatics, but refined over centuries into something so smooth, so reliable, that we barely notice it anymore. But tonight, we will notice. Tonight, we will appreciate every innovation, every careful thought that went into making these silent servants of our daily lives. Let us go back to the beginning. The year is 1931. The place is Pennsylvania. A man named D. Horton stands in his workshop, surrounded by plans and prototypes. He's trying to solve a problem. How can a door know when to open? In his mind, he sees busy people, their arms full of packages, struggling with heavy doors. He sees elderly individuals hesitant at entryways. He sees a world that could be more accessible, more welcoming. Breathe in slowly, hold it, release. Horton's first automatic sliding door opened at Wilcox's Pier restaurant in Pennsylvania. It was operated by a mat-actuated switch, a simple yet brilliant mechanism. Picture this. Beneath a rubber mat at the entrance lay a series of pressure-sensitive switches. When someone stepped onto the mat, their weight would compress it, pushing electrical contacts together and completing a circuit. This circuit would then trigger the door to open. The mat-actuated switch was elegant in its simplicity. Think of it as the door sensing the weight of your presence, the physical reality of your body pressing down through your shoes, through the mat, into the switch beneath. It required no electricity to detect you, only the ancient force of gravity, your mass against the earth, creating enough pressure to bridge a gap between two metal contacts. Feel the weight of your own body now, sinking into your bed, into comfort and rest. But innovators dreamed of something even more responsive, something that could sense your approach before you even reached the threshold. In the 1960s, the magic eye was born. The magic eye, what engineers call a photoelectric sensor, works on the principle of light itself. Imagine a beam of infrared light, invisible to your eyes, stretching across the doorway like a silent guardian. On one side stands an emitter, constantly broadcasting its ray. On the other side sits a receiver, always listening, always watching for that beam. When you approach, your body interrupts the light. You cast a shadow in a spectrum you cannot see. The receiver notices immediately. The beam has been broken. In that instant, faster than thought, an electrical signal rushes to the door's control system. Someone is here. Open. The magic eye revolutionized automatic doors because it could sense intention. You didn't need to step on anything or touch anything. You merely had to approach, to exist in the space, and the door would know. Think of it now. How many times have you walked through a door opened by a magic eye? Hundreds? Thousands? Each time, a beam of light was interrupted by your presence, and machinery responded to welcome you. Close your eyes and picture that invisible beam, that patient light, waiting in doorways all over the world. Let's return to that pneumatic hiss, that soft exhalation that accompanies every opening. Inside the door's mechanism lies a world of compressed air, of chambers and valves and carefully sealed cylinders. When air is compressed, it stores energy, potential energy waiting to be released. The compressor takes air from the atmosphere and squeezes it into a smaller space, increasing its pressure. This pressurized air is stored in a tank, ready at a moment's notice. When the signal comes to open, a solenoid valve clicks open. The compressed air rushes through tubes to the pneumatic cylinders attached to the door. Inside each cylinder is a piston, a disc that fits snugly inside the cylinder's tube. On one side of the piston, pressurized air flows in. On the other side, air can escape through a controlled release valve. The pressure differential pushes the piston forward, and the piston is connected to a rod, and the rod is connected to the door. The door moves, smoothly, steadily. At exactly the right speed, not too fast to startle, not too slow to frustrate. As the door reaches its open position, another valve activates, holding it there with continued air pressure. The door waits, patient and still. Then, after a programmed delay, usually 3 to 5 seconds, carefully calculated to allow people to pass through without rushing, the system reverses. Air pressure shifts. The door begins to close just as smoothly as it opened, and that hiss you hear. That's the sound of air being released in a controlled manner, the pneumatic system exhaling as it completes its cycle. It's a sound of completion, of function fulfilled, of systems working in perfect harmony. Listen to your own breath now. In and out, like the door, like the pneumatic system, a natural rhythm of opening and closing. But what if something goes wrong? What if someone is still in the doorway when the door begins to close? This is where the contact ribs, also called safety edges, become the door's conscience. Imagine rubber strips running along the leading edges of the door panels. These aren't ordinary rubber strips. Inside each one runs a switch mechanism, sometimes a simple electrical circuit, sometimes a pneumatic air tube. These are the contact ribs, and they are always vigilant. The moment the contact rib touches an object, a person, a wheelchair, a shopping cart, a small child's hand, it responds instantly. The switch activates, or the air tube compresses, sending an immediate signal to the control system. Stop, reverse, open. The door halts its closing motion in milliseconds. It reverses. It opens fully again, giving the person or object time to clear the entryway. Only then will it attempt to close once more. The contact ribs are made from flexible polyvinyl or rubber compounds, soft enough not to harm, sensitive enough to detect even gentle pressure. They've prevented countless injuries, protected thousands of people who weren't quite through the doorway, who hesitated, who stumbled, who needed just one more moment. Think of them as the door's sense of touch, its ability to feel the world and respond with care. In a machine, this is a profound gift. The gift of gentleness, of knowing when to yield. Feel that gentleness now in your own body. No force, no pressure, just yielding to rest. Now imagine a different scenario. A building is crowded. Perhaps it's a shopping mall during the holidays, or an office building at closing time. Suddenly, an emergency, an alarm. People rush toward. The exits, automatic doors in this moment, could become obstacles. What if the power fails? What if the systems don't respond quickly enough to the surge of people? This is why automatic doors include a breakout safety feature, one of the most important innovations in door technology. Breakout allows a sliding door to be pushed open manually with a reasonable amount of force, even if the automatic opening system has failed or if the door is attempting to remain closed. The door panels are mounted on a specialized track system with releases that will disengage when sufficient outward force is applied, typically around 30 to 50 pounds of pressure. When someone pushes hard against a door with breakout functionality, the door panels separate from their motor-driven carriage and swing open, unobstructed. The panels essentially break free from the automated system, becoming manual doors in an instant. This feature has saved lives. During power outages, during system failures, during moments when crowds needed to exit quickly, the breakout feature transformed an automated door back into something more primitive, but more essential, a simple opening that yields to human need. After the emergency, technicians can reset the door, reconnecting the panels to their automated system. But in that crucial moment, the door chose human safety over mechanical precision. Think of this as you drift towards sleep. Sometimes the most important feature of any system is knowing when to let go, when to give way, when to release control, and simply allow passage. Let go now. Allow yourself passage into rest. The mat-actuated switch and the magic eye were just the beginning. As decades passed, automatic doors learned to sense in new and more sophisticated ways. Microwave motion sensors emit radar waves, detecting movement within a cone-shaped pattern extending outward from the door. These sensors can detect motion through glass and light barriers. They sense velocity and direction, distinguishing between someone approaching the door and someone merely standing nearby. Ultrasonic sensors emit high-frequency sound waves beyond human hearing. These waves bounce off objects and return to the sensor. By measuring the time it takes for the echo to return, the sensor can determine how far away an object is and whether it's moving toward or away from the door. Passive infrared sensors detect heat signatures. Your body radiates warmth, invisible, infrared light that these sensors can detect against the cooler background. When your heat signature moves into the sensor's field of view, the door awakens. Some modern doors combine multiple sensing technologies: infrared and microwave, motion, detection and pressure mats. This redundancy ensures reliability. If one system fails to detect you, another will. The door will open, you will be welcomed. And through all these technologies, through all these methods of detection, runs a single thread: the desire to sense human presence, to respond to human need, to make the act of entry effortless. You are sensed now by the world around you. You are known. You are safe. You can rest. That pneumatic hiss we mentioned earlier, let's linger on it for a moment longer. In the quiet of late night, in an empty building, that hiss is the only sound. It's the voice of industry, of machinery, of compressed air finding. Release. It's a sound that would have astonished people a century ago. A sound that represents countless innovations in fluid dynamics, materials science, and mechanical engineering. The air compressor that creates this pressure is itself a marvel. It draws in atmospheric air through an intake valve. A piston or rotary screw compresses this air, forcing it into a smaller volume. As the volume decreases, pressure increases. This is Boyle's law, a fundamental principle of physics discovered in the 17th century by Robert Boyle, an Irish natural philosopher who wondered what would happen if you squeezed air into an increasingly small space. The compressed air is stored in a tank, typically pressurized to 90 to 120 pounds per square inch, far greater than the 14.7 pounds per square inch of normal atmospheric pressure. This stored energy waits, patient and ready. When the door needs to move, valves open, and this pressurized air rushes through tubes, usually made of polyurethane or nylon, flexible yet durable, into the cylinders. The air pushes the pistons move the doors, and when the air is released, either through controlled vents or back into the atmosphere, it creates that distinctive hiss. It's a sound of completion, of purpose fulfilled, like a sigh of satisfaction. Let yourself sigh now. Release the breath you've been holding. Let the tension flow out with your exhalation, like air from a pneumatic system, like a door completing its cycle. The speed at which an automatic door opens and closes is not arbitrary. It's the result of careful calculation, balancing efficiency with safety. Doors typically open at speeds between 1.5 to 2.5 feet per second. This seems slow by mechanical standards. A car on a highway travels at 88 feet per second, but it's perfect for human interaction. Fast enough that you don't feel you're waiting, slow enough that you're never startled or at risk of collision. The closing speed is usually slightly slower, around 1 to 1.5 feet per second, giving people extra time to clear the threshold. The door begins closing at this slower pace, then may speed up slightly during the final portion of its travel when the doorway is clearly empty. These speeds are achieved through the regulation of airflow in pneumatic systems or through precisely controlled electric motors in motor-driven systems. Flow control valves adjust how quickly air can enter or exit the cylinders. Variable speed motors adjust their rotation rate based on feedback from encoders that measure door position. The dwell time, how long the door remains fully open, is equally calibrated. Too short, and people feel rushed or may be struck by a closing door. Too long, and the door wastes energy and allows excessive air exchange between indoors and outdoors. Standard dwell times range from 3 to 5 seconds for normal traffic, but can extend to 8 or 10 seconds in locations serving elderly individuals or people with mobility challenges. The door is programmed to be patient, to accommodate the pace of those who move through it. Think of this patience as you settle deeper into rest. There is no rush. The night is long. Time stretches out before you like a doorway held open, waiting for you to pass through at your own pace. Every automatic door you pass through carries within it the weight of history, the accumulated knowledge of generations of engineers and inventors. After D. Horton's first automatic sliding door in 1931, the technology spread slowly at first. During World War II, development paused as industrial capacity focused on military needs. But after the war, in the economic boom of the 1950s, automatic doors began appearing in supermarkets, department stores, and office buildings across America. In 1954, the American Standard Company introduced a line of automatic doors specifically designed for commercial applications. In 1960, the Electric Eye Company refined photoelectric sensors for door activation. Throughout the 1960s and 70s, pneumatic systems improved, becoming quieter, more reliable, more energy efficient. The 1990 Americans with Disabilities Act in the United States accelerated innovation in automatic door technology. Suddenly, accessibility wasn't optional, it was law. Doors needed to accommodate wheelchairs, walkers, people with limited mobility. Push buttons for door activation appeared at wheelchair height. Sensing zones expanded. Opening and closing speeds were standardized to ensure safety. Today, automatic doors are everywhere. In hospitals, where hands must remain sterile. In airports, where travelers struggle with luggage. In hotels, creating an atmosphere of effortless hospitality. In office buildings, managing the flow of hundreds or thousands of people each day. And in every one of these doors lives that original vision. D. Horton's vision of a world where entry is effortless, where technology serves human need, where we are welcomed. You are welcomed now into sleep. The doors of rest are open. Pass through without effort. Let's return once more to the magic eye, to that invisible beam of light stretching across doorways. The photoelectric sensor emits infrared light continuously, thousands of times per second. The receiver checks for this light just as frequently. This constant vigilance requires patience, a patience that is programmed, yes, but patience nonetheless. Imagine standing watch, looking for a signal, every moment of every day, for years. This is what the magic eye does. It never sleeps. It never becomes distracted. In the coldest winter night, or the hottest summer afternoon, in the crowded rush of morning, or the empty silence of 3 a.m., the magic eye watches. Infrared light is used because it's invisible to humans. Our eyes detect only wavelengths between about 380 and 700 nanometers, while infrared begins at 700 nanometers and extends far beyond. The sensors typically use near-infrared, around 850 to 940 nanometers, a wavelength that passes through clear glass and plastic without significant absorption. The emitter contains an LED, a light-emitting diode, that converts electrical current directly into light with remarkable efficiency. The receiver contains a photodiode, or phototransistor, that does the opposite, converts light back into electrical current. When the beam is unbroken, current flows steadily through the receiver. The control system interprets this as doorway clear, remain closed. When you step through the beam, the current stops. The absence of signal is itself a signal, the most important signal. It means someone is here. Open now. There's a poetry to this: detection through absence, through interruption, through the shadow you cast. You cast a shadow now in the darkness of your room. You are here, present, real. And like the magic eye, the world acknowledges your presence, responds to it, makes space for you. The glass in automatic doors is not ordinary glass. It's typically tempered glass, glass that has been heated to approximately 200 degrees Fahrenheit and then rapidly cooled. This process creates compression on the surface and tension in the interior. making the glass 4 to 5 times stronger than standard annealed glass. If tempered glass does break, it shatters into small, relatively harmless pebbles rather than in sharp shards. This is crucial for safety in high-traffic areas where thousands of people pass through each day. The door tracks are usually aluminum extrusions, aluminum that has been heated and forced through a die to create specific shapes. Aluminum is chosen for its strength-to-weight ratio, its resistance to corrosion, and its smooth surface that allows for low-friction sliding. The wheels or rollers that support the door panels as they slide are often made from nylon or polyurethane, materials that combine durability with quiet operation. These wheels can support hundreds of pounds while making almost no sound as they roll along the track. The contact ribs we discussed earlier are made from flexible rubber compounds, often EPDM, ethylene propylene DNA monomer rubber, which maintains its flexibility across a wide temperature range and resists degradation from sunlight and weather. Every material is chosen with care. Every component is designed to withstand not just hundreds, but millions of cycles, openings and closings, day after day, year after year. A busy automatic door might open and close 250,000 times per year. Over a typical 20-year lifespan, that's 5 million cycles, 5 million openings, 5 million closings, 5 million pneumatic hisses, 5 million moments of sensing and responding, and through all of this, the door persists, serving, functioning, welcoming. Let yourself persist now in this moment of rest. You need not do anything, simply be, as the door simply is, present and available. Behind every automatic door is a control system, a computer essentially, though we rarely think of it that way. This control system receives inputs from all the sensors: the mat-actuated switch, the magic eye, the motion detectors, the contact ribs. It processes these inputs according to programmed logic. If sensor A activates and sensors B and C show clear doorway, then initiate opening sequence. If contact rib activates during closing, then immediately reverse to full open position. Modern door control systems are microprocessor-based, containing chips not unlike those in your computer or smartphone, though far more specialized. They do run the same program continuously, checking sensors, controlling valves or motors, monitoring safety systems. These control systems can be programmed with different modes. Some doors have a summer mode and a winter mode. In winter, the door might open more slowly to minimize heat loss, or the dwell time might be shorter. Some have different settings for different times of day, opening more eagerly during business hours, more cautiously in the evening. The control system also monitors itself. It checks that sensors are functioning, that the door is moving at the correct speed, that safety features are operational. If it detects a problem, a sensor failure, a door moving too slowly, a contact rib that isn't responding, it can shut down the automatic function and alert maintenance personnel. This self-awareness, this constant self-monitoring, is a form of care. The door takes care of itself so it can take care of you. Take care of yourself now. Notice your breath, your heartbeat, the weight of your body. Your own systems, monitoring and maintaining, allowing you to rest. An automatic door requires energy to operate, but less than you might think. A typical automatic sliding door system draws between 100 and 300 watts when actively opening or closing. When standing open or closed, which is most of the time, power consumption drops to less than 10 watts, just enough to keep the control system active and the sensors monitoring. Over a year, a busy door in continuous operation might use 500 to 1,000 kilowatt hours of electricity, roughly the same amount of energy as a home refrigerator. For the convenience and accessibility it provides to thousands of people, this is remarkably efficient. Some modern doors recover energy through regenerative systems. When the door closes, rather than dissipating the energy as heat, the system captures it and stores it in capacitors or batteries. This recovered energy can then assist with the next opening cycle, reducing overall power consumption by 20 to 30%. There's an elegance to this, energy flowing in cycles, being captured and reused, nothing wasted. It mirrors the natural cycles of the world, day and night, inhale and exhale, waking and sleeping. You are in the sleeping phase now. Your body is conserving energy, recovering, preparing for tomorrow's waking phase. Like the door, you are cycling through states of activity and rest, and in this rest, you are being restored. Not all automatic doors use pneumatic systems with their characteristic hiss. Many modern doors use electric motors, usually brushless, DC motors that operate in near silence. These electric systems replace compressed air with electromagnetic forces. The motor spins a drive belt or chain connected to the door panel. Electronic speed controllers regulate the motor's rotation with precision, accelerating the door smoothly from rest, maintaining constant speed during opening, and decelerating gently as the door reaches its fully open position. Without the pneumatic hiss, these doors move in an eerie quiet. You hear only the faint hum of the motor, the soft whisper of wheels rolling on tracks. For some, this silence is preferable, less industrial, more refined. For others, the pneumatic hiss is comforting, a signal that the door is working, that air pressure is sufficient, that all is well. Sound, or the absence of sound, creates atmosphere. In a hospital, silence is healing, suggesting cleanliness and calm. In a shopping mall, some acoustic presence is reassuring, a subtle reminder of activity and safety. Engineers design for these psychological effects as much as for mechanical function. Every choice, pneumatic or electric, fast or slow, loud or quiet, shapes how we experience these everyday miracles. Listen now to the silence of your room. Perhaps there is a hum of a distant appliance, the soft sound of air moving. Through vents, the creak of your house settling. These are the sounds of systems functioning, of your environment maintaining itself. Let these sounds comfort you, or let the silence embrace you. Either way, you are held. In the early morning hours, before most people arrive, maintenance technicians visit automatic doors. They carry with them toolboxes, lubricants, diagnostic equipment. They check the tracks for debris, sand, dust, small stones that might have accumulated. They clean the photoelectric sensors, wiping away dust that could interfere with the invisible beam. They test the contact ribs, pressing them to ensure they still respond instantly. They listen to the pneumatic system, detecting any irregularities in the hiss that might indicate leaking seals or failing valves. They examine the control systems logs, which record every opening, every safety activation, every anomaly. They adjust parameters if needed. Perhaps the door is closing too quickly, or the dwell time needs extending. This care, this regular maintenance, is why automatic doors are so reliable. Left alone, any mechanical system will eventually fail. But with attention, with care, with the knowledge of how things work and what they need, a door can function for decades. Your body too requires maintenance. Sleep is part of that maintenance, the time when cells repair themselves, when memories consolidate, when the systems that keep you alive perform their essential upkeep. By resting now, you are maintaining yourself, ensuring that tomorrow you will function as smoothly as a well-maintained door. Doors have always held symbolic meaning. They represent transition, threshold, passage between worlds. When a door opens automatically without our touch, this symbolism deepens. In cultures around the world, hospitality is expressed through welcoming entry. An automatic door embodies this hospitality without requiring a human presence. The building itself seems to welcome you, to acknowledge your arrival. There's something almost magical about it. The door opening as if by invisible hands, as if the building knows you're coming and is pleased to receive you. Children especially delight in this. Watch a young child approach an automatic door for the first time. Their face lights up with wonder. They may step back and forth through the sensor's range, triggering the door repeatedly, amazed that their presence alone can cause this large glass panel to move. This sense of being sensed, of having effect on the world simply by existing, is profound. The door says, you matter, your presence causes change, you have impact. In this moment, resting in darkness, you might feel you have no impact. But you do. Your presence in this world matters. You cause ripples, create effects, change the lives of those around you. Like approaching a door, simply being yourself is enough to create response, to cause opening, to make way. The automatic Doors of today may seem sophisticated, but innovation continues. Researchers are developing doors that can recognize individuals through facial recognition or gait analysis, adjusting their behavior based on who approaches. A door might open more slowly for an elderly person it recognizes, remain open longer for someone carrying packages. Some experimental doors use artificial intelligence to predict traffic patterns, adjusting their sensitivity and speed throughout the day based on learned patterns. During morning rush, the door becomes more eager, opening with less trigger, staying open longer to accommodate streams of people. During quiet periods, it becomes more conservative, saving energy. There are even doors being tested that generate their own power, through solar panels integrated into the glass or through piezoelectric materials in the floor mat that convert the pressure of footsteps into electricity. The door becomes self-sustaining, powered by the very people who use it. But perhaps the most profound direction is toward universal design, doors that accommodate every body, every ability, every need. Doors that lower themselves for children or wheelchair users, that provide audio cues for the blind, that remain open longer for anyone who needs more time. The goal is a world where entry is effortless for everyone, where doors never present barriers, where technology serves every human without exception. We're not there yet, but we're moving in that direction, one door at a time, one innovation at a time. And you are part of this world of increasing accessibility, increasing care, increasing recognition that every person deserves ease of passage through space. Rest. Now in that knowledge, every door has stories, though it cannot tell them. Think of all the reunions at airport doors. Families embracing as the door glides open, welcoming travelers home. Think of all the first days at new jobs, nervous individuals approaching office building doors, taking deep breaths as the panels slide apart. Think of all the medical emergencies where doors opened immediately for rushing paramedics. Think of all the children who've entered libraries through these doors, beginning a love of reading. Think of all the elderly people who've maintained their independence because they could enter buildings without struggling with heavy manual doors. Each door has witnessed thousands of human moments, joys and sorrows, beginnings and endings, the mundane and the extraordinary. It opens for all equally. It doesn't judge whether your errand is important or trivial. It simply senses and responds. There's a lesson in this equanimity, this impartial service. The door teaches us to be present, to respond to what is needed, to welcome without prejudice. As you drift towards sleep, let yourself be like the door, present, but not effortful, responsive but not demanding, open to whatever comes. We've spent so much time on the opening, but the closing is equally important. After you pass through, after the dwell time expires, the door must close. This is essential. It maintains climate control, security, and the boundary between inside and outside. But the closing must be gentle, safe, aware. The door begins to move. The contact ribs remain sensitive, ready to halt at the slightest touch. The safety sensors continue monitoring the threshold. If anything enters the doorway, a person, a pet, a cart, the closing immediately reverses. Only when the control system is certain the threshold is clear does the door complete its closing. The panels meet with a soft click or simply come to rest against rubber gaskets. The seal forms. The cycle is complete. The door returns to its neutral state, waiting for the next activation, ready to begin again. It is patient. It has closed millions of times. It will close millions more. Each closing is the same, yet each is new, responding to current conditions, current needs, current safety requirements. Your day too is closing. You've moved through waking hours, through activities and interactions, and now you're closing that cycle, entering rest. Like the door, you'll complete this closing gently, safely, taking all the time you need. And tomorrow, you'll open again, ready for a new cycle. Let's return once more to the contact ribs and the breakout feature, exploring the careful calculations that ensure safety. When a contact rib detects an obstruction, the door must reverse within a specific time frame, typically 0.3 to 0.5 seconds. This reaction time is based on studies of human pain tolerance and injury prevention. Engineers calculated that a door closing at 1.5 feet per second can safely contact a person if it reverses within this time frame. The force is spread across the soft contact rib, and the reversal happens before any harmful pressure accumulates. The force exerted by a closing door is carefully limited, usually to no more than 15 to 30 pounds at any point. This is tested during installation and regular maintenance using force gauges. If the door can exert more force than this, adjustments are made, closing speed is reduced, or pneumatic pressure is decreased. The breakout feature is calibrated to activate with 30 to 50 pounds of force. Enough that it won't activate from wind or accidental contact, but well within the capabilities of someone pushing to escape. These numbers, 0.3 seconds, 15 pounds, 50 pounds, represent the careful balance between function and safety. They're the result of engineering standards developed over decades, informed by accident reports, laboratory testing, and real-world experience. Safety in design is not about eliminating all risk. That's impossible. It's about understanding risk, calculating acceptable thresholds, and building in multiple layers of protection. The contact ribs are one layer. The photoelectric sensors are another. The breakout feature is a third. Together, they create a system that is remarkably safe, that has prevented countless injuries. Feel safe now, in this moment. Your bed supports you, your walls shelter you. Multiple systems in your home, electrical, structural, environmental, are working to keep you safe as you rest. Time moves differently for a door than it does for you. For you, a day is full of variety, work, meals, conversations, activities. For a door, a day is a series of identical cycles, repeated hundreds or thousands of times. Open, dwell, close, wait, detect, open, dwell, close, wait. Yet within this repetition, there are variations. Each person who approaches is different, taller, or shorter, faster or slower, alone or in groups. Each activation is unique in its timing, its duration, its minor details. The door experiences time as rhythm. The rhythm of morning rush. The quiet syncopation of midday, the gradual crescendo toward evening closing time. The long silence of night. If the door could speak, could think, what would it make of its existence? Would it find meaning in service? Would it take satisfaction in reliability? Would it notice the changing seasons through the temperature differentials between inside and outside? These are foolish questions, perhaps. The door is not conscious. And yet, in its persistent functioning, in its unfailing response to human presence, there is something worthy of respect, even gratitude. How many times have you passed through automatic doors without thinking about them? Thousands, probably. Each time, you were served by this patient technology, this synthesis of pneumatics and sensors and logic. Tonight, you've spent time thinking about doors. You've honored them with attention. And in doing so, perhaps you've learned to notice the systems that support you, the technologies that serve you, the invisible infrastructure of your daily life. Time for you is now moving towards sleep, toward the dissolution of conscious awareness. Let it flow naturally, like air through pneumatic valves, like a door completing its closing cycle. A door marks a threshold, a boundary between here and there, inside and outside, private and public. The automatic door transforms this threshold, where once a door required decision and effort, you had to reach out, grasp the handle, pull or push. Now the door anticipates. It recognizes your intention before you act on it. You need only approach. This anticipation changes the phenomenology of entry. You don't engage with the door, you simply continue moving, and space opens before you. The boundary becomes permeable, almost transparent. Philosophers might say the automatic door reduces friction in lived experience. Architects might say it dissolves the distinction between interior and exterior. Engineers might simply say it works. But for you, passing through, it means one less small challenge in your day. One less moment where accessibility could be an issue. One less barrier between you and your destination. The threshold is still there. You can see it in the frame, feel it in the change of temperature, sense it in the shift from outside to inside. But the threshold no longer resists. It welcomes. As you approach sleep, you're crossing a threshold, from waking to sleeping, from consciousness to unconsciousness. This threshold, unlike a door, cannot be automated. You must cross it yourself. But you can cross it gently. You can approach without resistance, allowing the transition to unfold naturally, like a door opening to your presence. Not all automatic doors slide. Let us explore the variations, the different ways engineers have solved the problem of automatic entry. The swing door, the most familiar type from our daily lives, can also be automated. Instead of sliding along tracks, these doors swing inward or outward on hinges. The automation comes from pneumatic or electric operators mounted above the door, connected to the door through an arm mechanism. When activated by a mat-actuated switch or magic eye, the operator pushes or pulls the arm, which swings the door open. The motion is slower than a sliding door, more stately, more deliberate. There's time to appreciate the arc of motion, the geometry of the swing. These doors are common in older buildings where the architecture demands traditional hinged doors, where sliding mechanisms wouldn't fit the aesthetic or the existing structure. The automation is added to heritage, bringing modern accessibility to historic spaces. Then there are folding doors, bifold or multifold panels that fold back on themselves as they open, like an accordion or a paper fan. These are used where space is limited, where a fully sliding door would require too much wall space, or where a wide opening is needed, but there's limited room for the door panels when open. The folding mechanism is more complex, with multiple hinges and synchronized movement. The pneumatic system, or electric motor, must coordinate the folding of multiple panels, ensuring they move together smoothly. When you watch a folding door open, you're seeing a ballet of synchronized motion, multiple parts moving in harmony. Revolving doors can also be automated. These large cylindrical structures, divided into segments by glass panels, rotate continuously or rotate on demand. Automated revolving doors sense when someone enters a segment and begin rotating at a comfortable, walking pace. They maintain climate control exceptionally well. There's never a fully open path between inside and outside, while still allowing continuous flow of people. Each variation solves different challenges. Each requires different engineering, but all share the same goal: effortless entry. Let your breathing become effortless now. No need to think about each breath. Let it happen naturally, automatically, like a door responding to your presence. Automatic doors exist in nearly every country now, but they're not identical everywhere. In Japan, automatic doors are often faster and more sensitive than elsewhere. The culture values efficiency and precision, and doors reflect this. They open almost instantly upon approach, close promptly after passage. The sensors are calibrated to detect people at greater distances, beginning the opening sequence earlier. In Northern Europe, where energy conservation is paramount, doors are programmed differently. They may require closer approach before opening. The dwell time might be shorter. Some buildings use vestibule systems, 2 sets of doors with a small space between, ensuring that inside and outside air never meet directly. In very hot climates, doors work hard against temperature differentials. The air conditioning inside creates significant pressure differences. The pneumatic systems must overcome not just the weight of the door, but also the air pressure trying to keep the door closed or push it open. Engineers adjust the systems accordingly, increasing pneumatic pressure or motor torque. In earthquake-prone regions, automatic doors include seismic safety features. If the building structure shifts during an earthquake, door frames can become misaligned and doors can jam. Special breakaway features allow the doors to separate from their tracks completely, rather than becoming trapped, ensuring emergency egress. The automatic door adapts to its environment, to local needs and conditions. This adaptability is itself a form of intelligence, not conscious intelligence, but the intelligence of good design, of systems that work in diverse contexts. You too adapt to your environment. Your body adjusts to temperature, to altitude, to time zones. Right now, your body is adapting to the state of rest, making countless small adjustments to support sleep. There are people whose entire profession is designing the sounds of doors, acoustic engineers who understand that sound is part of user experience. The pneumatic hiss we've discussed isn't random noise. Its pitch, volume, and duration are all results of design choices. The size of the air release ports determines pitch. Smaller ports create higher-pitched hisses. Larger ports create deeper ones. The release rate affects duration. Baffles and mufflers can soften the sound or change its character. Some acoustic engineers aim for near silence, designing release systems that vent air slowly through sound-dampening chambers. Others believe the hiss is reassuring, that silence is uncanny, and they design for a soft but audible release. The click of a door closing can be engineered too. Some doors use magnetic catches that produce a satisfying soft click. Others use rubber gaskets that compress with a whisper-quiet seal. The choice depends on the environment. In a library, silence is golden. In a shopping mall, a gentle click provides feedback that the door is properly closed. Even the hum of electric motors is carefully managed. Motors can be mounted on vibration-isolating pads. Gears can be manufactured to tighter tolerances to reduce noise. Drive belts can be made from materials that don't squeal or whine. Sound design extends to warning signals too. Some doors emit soft beeps when they're about to close, alerting anyone nearby. These beeps are carefully frequency-tuned to be noticeable without being shrill, to carry well without echoing harshly in tiled hallways. The goal is to create an acoustic experience that enhances rather than detracts from the space. Sound can make a place feel welcoming or institutional, modern or dated, caring or indifferent. Listen now to the sounds of your environment. Are they harsh or gentle, intrusive or ambient? Let the gentle sounds soothe you, and let the harsh ones fade to background, unimportant. In regions with harsh winters, automatic doors face special challenges. Ice can form on tracks. Snow can accumulate in sensors. Extreme cold makes materials brittle, makes rubber seals contract, makes lubricants thicken. Winter-rated doors use special components. The rubber in contact ribs is formulated to remain flexible at temperatures well below freezing. The wheels or rollers are made from materials that don't become brittle in cold. Pneumatic systems may include air dryers to prevent moisture in the compressed air from freezing inside the lines. Some doors include heating elements, thin electrical resistance heaters embedded in the tracks to melt ice, or infrared heaters above the doorway to create a warm air curtain that prevents snow accumulation. The mat-actuated switch must work even when covered by snow or wet with slush. Sealed designs keep moisture out of the electrical contacts. Some mats include drainage systems so water doesn't pool on the surface. The magic eye must see through falling snow, through frost on windows, through the steam that forms when warm, indoor air meets cold, outdoor air. Engineers use specific wavelengths of infrared that penetrate moisture more effectively, or they position sensors to avoid areas where condensation forms. In the deep cold of a northern winter, when the door opens, there's a visible plume of warm air rushing out, condensing in the frigid air. The door is creating a portal between two different worlds: the warm, controlled environment inside and the harsh, natural environment outside. The automatic door becomes a guardian of comfort, a keeper of warmth, yet it still opens when approached. Even in a blizzard, even in ice and snow, the door senses and responds. It persists in its function. You persist too. Through difficult seasons, through challenging times, you continue. Right now, you're persisting through the day into night, continuing into rest. Imagine opening the control system's memory, reading the log of everything that's happened. Entry 1543,882. Magic eye activated, 0.7 seconds. Door opened. Dwell 4.2 seconds. Door closed. No issues. Entry 1543,183. Magic eye activated, 0.4 seconds. Door opened. Contact rib activated during closing at 2.3 seconds. Immediate reversal. Full open. Dwell extended to 6.0 seconds. Door closed successfully. No issues. Entry 1543,884. Magic eye activated. 0.6 seconds, door opened. Dwell, 4.0 seconds, door closed, no issues. Entry 1543185. Manual open button activated, door opened. Dwell, 8.0 seconds, extended time setting, door closed, no issues. On and on, thousands of entries per day, millions over years. Each entry a moment in someone's day. Someone arriving at work, leaving the hospital, entering a store, exiting a building. The log also records anomalies. Sensor failures are noted with timestamps. Instances where the door moved more slowly than expected. Times when power fluctuated. Patterns that might indicate developing problems. A contact rib that's activating slightly more often, suggesting it's becoming misaligned. A motor drawing slightly more current, suggesting worn bearings. Maintenance technicians read these logs like doctors reading medical charts. They spot trends before they become failures. They schedule preventive maintenance. They keep the door healthy. The log is the door's memory, its record of service, its testament to function. If a door could feel pride, it would be in this log. Evidence of millions of successful cycles, of service rendered, of people helped. Your own body keeps logs too, your heart rate variability, your sleep patterns, your circadian rhythms. These biological logs are being written right now as you rest. They'll help your body maintain itself, heal itself, prepare itself for tomorrow. There's a moral dimension to automatic doors that's worth contemplating as you rest. Before automatic doors, many buildings were effectively inaccessible to people with certain disabilities. Heavy manual doors were insurmountable obstacles for wheelchair users, for people with limited strength, for those using crutches or walkers. The automatic door changed this. Suddenly, entry was possible. Independence was restored. A person who previously needed to wait for assistance, who felt the indignity of being unable to enter a building unaided, could now simply approach and be welcomed. This is what engineers call universal design, creating things that work for everyone, not just for the average or able-bodied user. The automatic door is perhaps one of the greatest successes of universal design. It helps everyone. Parents with strollers, delivery workers with packages, elderly individuals with reduced mobility, and yes, people with disabilities. What's remarkable is that the door helps all these groups with the same mechanism. There's no special accessibility door and regular door. There's just a door that senses presence and responds. In its automatic function, it makes no distinctions. This is equality through technology. Not treating everyone the same, but responding to everyone's need in the same way. The door doesn't care why you need it to open, it simply opens. There's a lesson here about how we might treat each other. Not making distinctions based on why someone needs help, just responding to the need. Not requiring justification, just providing access. As you rest, let go of justifications. You don't need to earn rest. You don't need to prove you deserve it. You simply need it, and that's enough. Let's linger once more on that pneumatic hiss, exploring it more deeply. Air is mostly nitrogen, about 78%. Oxygen makes up about 21%. There are trace amounts of argon, carbon dioxide, and other gases. When you compress this mixture, you're forcing all these molecules closer together. At atmospheric pressure, at sea level, air molecules are relatively far apart. They bounce around randomly, colliding with each other and with the walls of any container. This random motion creates pressure, the cumulative effect of billions upon billions of tiny collisions per second. When you compress air into a smaller volume, the molecules don't change, but their density increases. More molecules occupy the same space. Collisions become more frequent, pressure rises. This pressurized air, stored in the tank, contains potential energy. The molecules are like coiled springs, compressed and ready to expand. When the valve opens, this potential becomes kinetic. The molecules rush through the valve, expanding into the larger volume of the pneumatic cylinder. This expansion pushes the piston. The piston pushes the rod pushes the door, potential energy becomes motion, and when the air is finally released to atmosphere through the vent, when it returns to normal pressure, it creates that hiss, the sound of expansion, of pressure equalizing, of energy dissipating. It's the same principle that powers your breathing. Your diaphragm creates negative pressure in your lungs, and air rushes in to equalize it. Your diaphragm relaxes, pressure increases, and air flows out. Breath in, breath out, compression and expansion. The same physics that powers doors powers life. Feel your breath now, the air entering your lungs, the gentle expansion of your chest, the soft release as you exhale. You are a pneumatic system, powered by air, cycling through pressure changes, living and breathing. It's 3 a.m. in an office building. The cleaning crew has gone home. The security guard makes rounds every hour. Between rounds, the building is empty, silent. The automatic doors are still active. The control systems are still powered. The magic eye still casts its invisible beam across the threshold. The compressed air is still ready in the tank, but no one approaches. The mat is undisturbed. The photoelectric beam remains unbroken. The door stands closed, waiting. What is it like to wait? The door has no consciousness, no subjective experience of time passing. Yet if it did, would these hours feel long? Or would the door simply exist in a state of readiness, patient and eternal? At 3:47 a.m., the security guard approaches on rounds. The magic eye detects him. The control system activates. The pneumatic valve opens. Air rushes through the lines. The door slides open with its characteristic hiss. The guard walks through, barely noticing. This is the 1,000th time he's passed through this door. It's as familiar as breathing. The door closes behind him. Silence returns. The door waits again. In these small hours, in this empty building, the door's function continues unabated. It doesn't rest. It doesn't sleep. It simply is ready to serve if needed, content to wait if not. But you can rest. You are not a machine. You need sleep, need to let go of readiness, need to sink into unconsciousness. The world will continue without your vigilance. Systems will function. Life will go on. You can let go. Let's explore the mat-actuated switch. More deeply, understanding exactly how pressure becomes signal. The mat is typically constructed in layers. The top layer is rubber or vinyl, durable and weather-resistant. Below this is a layer containing the switches themselves. In the simplest design, 2 thin metal plates are separated by a small gap, held apart by rubber spacers. When you step on the mat, your weight compresses the rubber spacers. The metal plates come into contact. Electricity can now flow between them. This change in conductivity is detected by the control system. In more sophisticated designs, the mat contains a pressure-sensitive resistor material. This material changes its electrical resistance when compressed. The control system constantly monitors this resistance. When it drops below a certain threshold, indicating sufficient pressure, the door is triggered to open. Some mats use piezoelectric materials, which generate a small electrical voltage when compressed. Your footstep creates a tiny pulse of electricity, like a knock on an electronic door. The sensitivity must be carefully calibrated. Too sensitive, and the door might open for small animals, or for snow accumulation, or for debris. Not sensitive enough, and a child or lightweight person might not trigger it. Engineers test with different weights, different pressures, different patterns of force application. They ensure that a wheelchair's small wheels create enough pressure. They ensure that someone walking very gently still triggers the system. They ensure that a shopping cart's wheels, distributed over 4 points, still activate the mat. The mat is patient with variation. It responds to light footsteps and heavy ones, to deliberate strides and tentative approaches. It makes no judgments about how you walk or why. It simply detects, weight present, open the door. Your bed is doing something similar right now. It's detecting your weight, your pressure points, and responding by supporting you. Feel that support. Let it hold you completely. When an automatic door opens in winter, it creates a momentary breach in the building's thermal envelope. Inside, the air might be 72 degrees Fahrenheit, carefully maintained by the heating system. Outside, it might be 20 degrees. That's a 52-degree differential. The moment the door opens, heat begins to flow. Warm air, being less dense, rises and flows out the top of the doorway. Cold air, being denser, flows in at the bottom. This is called the stack effect. The building's heating system must work harder to replace this lost heat. Energy is consumed. But this is the cost of accessibility, of welcoming entry, and it's generally considered worthwhile. Some buildings use air curtains, powerful fans mounted above the doorway that blow a sheet of air downward when the door opens. This air curtain acts like an invisible barrier, reducing the exchange of indoor and outdoor air. It doesn't completely prevent heat loss, but it significantly reduces it. The door itself doesn't care about temperature. Its components function across a wide range. But the door exists within these energy considerations, these thermodynamic realities. In summer, the gradient reverses. Now cool air-conditioned air wants to flow out, and hot, humid air wants to flow in. The door still opens, the air curtain still helps, energy is still consumed, the system persists. You maintain your own temperature gradient. Your body is generating heat, keeping your core at 98.6 degrees even as the room around you is cooler. Your blankets help maintain this gradient, creating a comfortable microclimate for sleep. Feel the warmth of your body, the coolness of the air on your face. Rest in this comfortable temperature, this carefully maintained balance. Imagine the day the door was installed. Workers arrived with crates and tools and plans. They began by preparing the opening. The door frame had to be perfectly level, perfectly plumb. Even a slight angle would cause problems. The door might drag, might not seal properly, might wear unevenly. They used levels and laser guides, adjusting shims and anchors until everything was precise. This patience, this attention to detail in the foundation, ensures years of proper function. The track was mounted next, carefully aligned. The door panels were lifted into place, heavy sheets of tempered glass in metal frames. The wheels, or rollers, were attached, adjusted for smooth rolling. The pneumatic system, or electric motor, was installed. Lines were connected. Wiring was run. The control system was mounted and connected to all the sensors. Then came testing. The installers triggered the sensors repeatedly, watching the door open and close, listening to the sounds, checking the speeds. They adjusted parameters, fine-tuned settings. They tested the contact ribs, pressing them to verify instant reversal. They tested the breakout feature, pushing hard to ensure it would release under the right amount of force. They measured closing, force with specialized gauges. Finally, they put a mat in front of the sensor area and walked through the door dozens of times, experiencing it from the user's perspective. Only when everything felt right, when the door welcomed them smoothly and reliably, did they sign off on the installation. That day of careful installation makes possible years of reliable service. The care invested then pays dividends in every subsequent opening. Your own body was carefully installed too. 9 months of development before birth, years of growth and learning afterward. All that careful preparation enables your function now. Rest in the knowledge that you are well made, carefully constructed, deserving of the same ongoing maintenance and care that keeps a door working. Modern automatic doors are often connected to building management systems, part of an invisible network of controlled devices. Through the network, the building manager can monitor the door remotely. They can see how many activations it's had today. They can check if any error codes have been logged. They can adjust settings without visiting the door physically. The door might communicate with the HVAC system. When the door opens frequently, say during a rush of morning arrivals, the HVAC system increases its output, compensating for the heat or cooling being lost. The door might coordinate with security systems. After business hours, the door might require badge access before it will open automatically. The control system communicates with the security panel, checking credentials before activating. In some sophisticated buildings, the door is part of an integrated access control and people counting system. It tracks how many people enter and exit, helping with occupancy monitoring, evacuation procedures, and space utilization analysis. The door has become more than a mechanical device. It's a node in a network, a sensor providing data, a controlled element in a larger system. It has gained a kind of digital awareness, an existence in software as well as hardware. Yet to you, passing through, it's still just a door. The complexity is hidden. The networking is invisible. You simply approach, and it opens. This is good design. Complexity hidden behind simplicity, capability disguised as ease. As you drift towards sleep, systems in your body are networking too. Your nervous system communicates with your endocrine system. Your brain coordinates with your muscles to keep you breathing, even when unconscious. All this complexity works invisibly, letting you simply rest. Some artists have used automatic doors in their work, recognizing the poetic potential in these everyday mechanisms. One artist created an installation where automatic doors opened onto unexpected spaces. One opened onto a garden, another onto a brick wall, a third onto a mirror. The familiar gesture of the door opening became a frame for surprise, for contemplation on expectations and reality. Another artist programmed a door to open at random intervals, regardless of whether anyone approached. The door opened to emptiness, welcomed no one, performed its function to the void. It became a comment on automation, on systems that persist regardless of need or use. A third artist inverted the usual relationship. They created a door that opened when you walked away from it and closed when you approached. This reversal was deeply unsettling to experience. The door seemed to reject rather than welcome, creating a visceral sense of wrongness. These artistic uses reveal how deeply the automatic door's behavior is embedded in our expectations. We've learned its language: approach and be welcomed, pass through, continue on. When that language is altered, we feel it immediately. The automatic door has become part of our environmental literacy, part of the vocabulary of modern-built space. We read it without conscious thought, just as we read traffic lights, escalators, and countless other design systems. As you move towards sleep, you're following another deeply embedded pattern: the circadian rhythm, the cycle of waking and sleeping that's been part of animal life for hundreds of millions of years. Your body knows this language too, this vocabulary of rest and activity. Let it guide you now. Eventually, after decades of service, a door might be rebuilt. The panels might be replaced with new glass, modern low-E coatings that improve energy efficiency. The tracks might be replaced with newer designs that roll more smoothly. The control system might be upgraded to a modern microprocessor-based unit with more capabilities. But often, the core mechanism remains. The pneumatic cylinders, if well maintained, can last 50 years or more. The basic architecture of sensors and response persists. This is the ship of Theseus problem. If you replace every component eventually, is it still the same door? Philosophically, perhaps not. But functionally, yes. The door still opens when you approach. It still serves the same purpose in the same location. What persists is not the specific materials, but the function, the pattern, the relationship between sensor and response. The door is less a thing than a behavior, less an object than a service. You too are being rebuilt constantly. The cells in your body are replaced on various schedules: skin cells every few weeks, red blood cells every few months, bone cells over years. After 7 years, very few of the atoms that make up your body are the same ones that were there before. Yet you persist. Your pattern persists. Your memories, your personality, your essential self continues even as the material constantly changes. You are not just a collection of atoms. You are a pattern, a process, a continuous becoming. Rest now in that continuous flow. Let's consider the economics of automatic doors, the cost and value calculations that surround them. An automatic sliding door system costs between $2,000 and $10,000 to purchase and install, depending on size and sophistication. This is significantly more than a manual door. Annual maintenance might cost $200 to $500. Electricity consumption might add another $50 to $100 per year. Over a 20-year lifespan, total cost of ownership might be $6,000 to $15,000. What does this buy? For a busy retail store, it buys customer convenience. People carrying purchases can enter and exit easily. This might translate to longer shopping times, more purchases. The door pays for itself in increased sales. For an office building, It buys accessibility compliance and reduced workers' compensation claims from door-related injuries. It buys a more professional image, a sense of modernity and care. For a hospital, it buys infection control. Staff with sterile hands never touch door handles. It buys accessibility for patients using wheelchairs, walkers, or gurneys. These benefits are difficult to quantify in dollars, but are immensely valuable. The automatic door is economically rational in many contexts, but economics doesn't capture everything. There's also dignity, the dignity of being able to enter a building independently without assistance. There's inclusion, the sense that spaces are designed for you, whoever you are. These intangibles have value beyond price. They're part of what makes a society function, what makes public space truly public. You don't need to justify your rest economically. Sleep isn't productive in the narrow sense, but it has immeasurable value for health, for cognitive function, for emotional well-being, for simply being human. Rest, not because it's economically rational, but because you need, and despite all the engineering, all the redundancy, doors sometimes fail. Understanding how they fail reveals how carefully they're designed. If the magic eye fails, the door might default to mat activation only. If the mat fails, the door might rely solely on the magic eye or require manual button activation. Redundancy means one failure doesn't mean total loss of function. If the pneumatic compressor fails, many systems have a manual release that allows the door to be pushed open by hand. The door loses its automatic function but retains emergency breakout capability. If the control system fails completely, the breakout feature ensures the door can still be forced open for emergency egress. Safety features are designed to fail safe, not fail closed. If power fails, battery backup systems keep the control system and sensors operating for several hours. The door continues to function on stored power, welcoming people even when the grid is down. These cascading fallbacks, from fully automatic to semi-automatic to manual to emergency breakout, represent layers of resilience. The door is designed to gracefully degrade, to lose capabilities one at a time rather than all at once. Your body has similar redundancies. If one kidney fails, the other compensates. If you lose some vision, your other senses become more acute. You have backup systems, redundant capacities, resilience built into your biology. Trust in these redundancies now. Your body knows how to sleep. If conscious effort fails, automatic processes take over. Let go of trying, and let the backup systems engage. Doors appear throughout literature as metaphors for transition, for opportunity, for choice. When one door closes, another opens, we say. This wisdom takes on new meaning with automatic doors. Sometimes the door opens without effort on our part. Sometimes opportunity presents itself simply because we approached, because we showed up. The automatic door reminds us that not all progress requires struggle. Sometimes things can be easy. Sometimes the way opens before us. Robert Frost wrote about the road less traveled, about choices that diverge. But automatic doors are democratic. They open for everyone who approaches. They don't require choosing. They simply welcome. In science fiction, automatic doors are ubiquitous, a shorthand for advanced technology. The whoosh of the doors on Star Trek's Enterprise became iconic. A sound of the future, of a world where barriers yield automatically to human presence. But we live in that future now. The automatic door is no longer science fiction. It's mundane, everyday, hardly noticed. The miraculous has become ordinary. What other miracles surround you, unnoticed because they're so common? The light at the touch of a switch. The water flowing from the tap. The warmth of your home, the bed that supports you. You are surrounded by marvels. Rest now in that abundance, that technological and material wealth that previous generations would have considered magical. Imagine a door that's been in service for 40 years. It was installed when the building was new. It has opened and closed perhaps 50 million times. It has welcomed millions of people, multiple generations passing through the same threshold. The technology has changed around it. When it was new, the control system used discrete electronic components. Now it's been upgraded to microprocessors. The sensors have been replaced multiple times, each generation more sensitive and reliable than the last, but the basic mechanism persists. The same pneumatic cylinders still push the door open. The same tracks still guide its motion. The door has been maintained, cared for, kept in service. 40 years is longer than many marriages, longer than most careers. This door has been a constant presence in its location, serving day after day, year after year, decade after decade. How many lives has it touched? How many people have passed through it without thinking, their minds on other things, a meeting they're late for, a purchase they want to make, a loved one they're visiting in the hospital? The door served them all equally. It asked nothing in return, only electricity and occasional maintenance. It gave accessibility, convenience, welcome. There's something profound about persistent service, about showing up day after day to do the same work. The door teaches constancy, teaches that reliability is its own form of excellence. You don't need to be extraordinary every day. Sometimes showing up, being present, doing what you're designed to do, that's enough. That's everything. Rest. Now letting go of the need to be remarkable. Simply be, as the door simply is. As our time together approaches its end, as you drift ever closer to sleep, let's return once more to the essential gesture, the opening. A door opens. Space that was separate becomes connected. Inside and outside cease to be completely distinct. There is now a passage, a way through. This opening is repeated countless times daily in countless locations worldwide. Each opening is the same, yet each is unique, occurring at a specific time for a specific person in a specific context. The mat-actuated switch detects weight. The magic eye detects presence. The contact ribs detect touch. The pneumatic system provides force. The control system coordinates everything. The breakout feature ensures safety. All these components, all these systems, all this careful engineering serves a single simple purpose: to open space for passage, and passage is fundamental to life. We are always passing through doorways, through days, through stages of life, through states of consciousness. Right now you are passing through the doorway between waking and sleeping. You don't need special technology for this passage. Your own body, your own biology knows the way. The door opens, you pass through. On the other side is rest, is sleep, is the deep unconsciousness that restores and renews. Let yourself pass through. Now, the way is open, the threshold is clear, you are welcomed, you are safe, you can rest. The door has done its work. Now sleep. End of story. Gentle rest to you.